A photon's pinball-like journey as it collides with and bounces off protons on its path out of the sun is a random walk like this, on a very small and a very big scale. This grid represents a bunch of protons in the sun's core. Let's say a photon is released by a fusion reaction here. It could go in any direction. Let's divide our directions like the 12-hour marks on a clock and then roll a 12-sided die. Okay, let's draw a straight line in that direction. We hit a proton, and our photon will bounce off in some other direction. Roll again. Draw a line in that direction, we hit. Let's roll again, go in that direction, and so on and so on. In the sun, this would be happening in 3 dimensions. But you can see that this is going to take a really long time. In fact, for the approximately 10 to the 57 protons in the sun spread out like our grid, the average distance between them ends up being 10 to the minus 10 meters, or about half the size of a water molecule. To random walk the 690 million meters from the solar core to the surface would require 10 to the 37 steps, which, calculating the random walk for a photon at light speed, is a journey of 100 billion years. Wait a sec. Okay, let's see here. So, okay, Big Bang as was. Just as I suspected, that's actually way older than the universe, and older than the sun, which only formed about 4.6 billion years ago. Photons of sunlight can't be hundreds of billions of years old. So where did we go wrong? Well, the actual random walk that a photon takes out of the sun is more complicated than our example, because unlike our simplified grid, the sun isn't the same density all the way through. It's very dense in its core, and it's less dense in the middle, and even less dense on the outside. And also, a photon won't always collide with every proton it meets. The physics is pretty complex and quantum-y here, but the important thing to realize is to a photon with lots of energy, a proton looks really small. And for a photon with less energy, a proton looks big. So as a photon loses energy along its pinball path, it changes the odds that it'll pew off of any given proton that it meets. When scientists put all of this together, the varying density of the sun and the changing energy of photons along the journey, and they plug it into big computers with math that would break my brain, the time that it takes for a photon to random walk from the sun's core to space is about 170,000 years.